Hello students, ever thought do two equations always meet at a single point? Today, let's break down the nature of solutions of simultaneous linear equations with real life examples in 5 to 10 minutes. Before we begin, click on the subscribe so you don't miss any easy math hacks, and in order to join our live classes, do check the link in the description. So let's begin our day number 18 challenge, which is simultaneous linear equations, the nature of solutions. So what does mean by nature of solutions? Whenever you solve two equations, three things can happen. The first thing, you get a unique solution, meaning that the two equations, which are nothing but straight lines, will meet at a single point. If you get no solution, it means that the two lines are parallel, which are not touching each other. Or if you get infinitely many solutions, that means the two lines are same, which means they overlap completely. This is called as nature of solution. But there is little more to this. Consistent versus inconsistent. If there is at least one solution, okay, either it's unique or infinitely many, then the system is called as consistent. If there is no solution, then it is called inconsistent. So consistent relates to the solution. Clear? The next thing, when two equations describe the same line, then they are dependent. When they describe different lines but still meet at a point, then independent. That's it. So this is all about our nature of solutions. So where it is used in our real life, in business, to check do two cost plans meet at the same target, or to check if two strategies will ever meet. In construction, checking if two designs constraints can work together. Market trends, to predict if demand and supply meet or never meet. Logic puzzles and in word problems, say for example lineage problems, prices, mixtures, we use this nature of solutions to predict our answers. So let's go into these nature of solutions in depth. So when two equations, say for example ax plus bx plus c equals to 0 is the general form of a linear equation. So now let's assume that the coefficients are a1 for x, b1 for y, and c1 is the constant or the known. Whereas a2 is the coefficient of the next line, b2 is the coefficient of the y of the next line, and c2 is the constant or the known quantity. If these two things are known clearly for us from an equation, then there can be three possible outcomes, as I told you. The first one is a pair of equations having a unique solution. That means the coefficients a1 by a2, if you put it in the ratio form, a1 by a2 is not equal to b1 by b2. Coefficient of x is, ratio of the coefficient of x is not equal to ratio of the coefficient of y. Then there will be a unique solution. Consider this example, 3x plus 5y equals to 21, 2x plus 3y equals to 13. Here if you put it in the ratio, 3 by 2 will not be equal to 5 by 3. Both the ratios are not same. That means this two system of equations will have only unique solution, and hence it is consistent. The two equations are independent equations. I hope you're clear with the first method. Now going to the second one. Now suppose assume that if both these are same, a1 by a2 equals to b1 by b2. If this is same, and also the third one, constant term is also same. The ratio of the constant term is also same. Literally, the ratio of every coefficient as well as the constant terms are same. Then there will be infinitely many solutions, which is nothing but they are just overlapping. Okay. Say for example, in this example, 2 by 4 equals to 3 by 6 equals to 10 by 20, which is basically 1 by 2 for everything. So all the coefficients, the ratio of the coefficients and the constant term are equal. So this means it has infinitely many solutions. So this is also consistent, but both the equations are dependent. Clear? Now coming to the third type, which is pair of equations having no solution at all. Here, though your coefficients, the ratio of the two coefficients are same or equal, the constants, the ratio of the constant will not be the same. Say for the example, in this one, 3 by 6 will be equal to 5 by 10. Both gives you 1 by 2. Whereas, if you take this constant term, it's 18 by 40, which is 9 by 20. Simplest form is 9 by 20. So this is not same as 1 by 2. That means the ratio of the constants are not equal. So it means this pair of equations will have no solution. So it is inconsistent. Okay. I hope you are clear with the first three methods. Now, let's quickly wrap up what we studied. If there is a unique solution, it means it is consistent and independent. If it is infinitely many solutions, then it is also consistent but dependent. If there is no solution, then inconsistent. Simple, right? Now let's see an example based on this. For what values of k is the system of equations become consistent, which means they should have at least a solution, one solution or many solutions. As you can see here, let us put it in the ratio form. 3 by 4 equals to 2 times k minus 1 divided by 2, and that is equal to 30 by 35. As you can see here, this, if all these are same, then it is consistent and infinitely many solutions. But here it is 3 by 4, whereas here it is 6 by 7. So obviously it will not have infinitely many solutions. But in order to be consistent, it should have at least unique or infinitely many. Infinitely many is not possible in this case. So it should be having a unique solution. That means A1 by A2 should not be equal to B1 by B2. So let's solve for this. When you cross multiply both the sides, you get 8 times k minus 1 should not be equal to 3 times 2, which is 6. So k minus 1 equals to 6 by 8. Let us put it in the lowest form. K minus 1 equals to 3 by 4. So k equals to 3 by 4 plus 1, which is nothing but 7 by 4. Sorry, it is should not be equal to 7 by 4. So the system of equations, the given system of equations are consistent for all the values of k except k equals to 7 by 4, which means k should not be equal to 7 by 4. Okay, I hope you're clear with this. Now comes the real challenge for you. Challenge number 18. The problem number 1 is, if two equations 2x plus ky equals to 6 and px plus 3y equals to 3 are dependent, then the values of k and p are what and what respectively. I hope you get the keyword from this question. The next one, for the system of equations 5x minus 3y equals to k and 10x minus 6y equals to 12, to be inconsistent, the value of k should not be equal to how much? Which is similar to our example problem. I hope you can do both the problems without any problem, right? If so, if this lesson really helped you, then click on the like button and do share it with a friend who really struggles with nature of solutions. And I'll find you again with the lesson answers in our next video. Thank you, and don't forget to post your answers. Bye-bye.